Alright, this is Mr. Best. Welcome to combinations of functions. We'll add, subtract, multiply, and divide functions, and we'll look at compositions of functions as well. The four operations, sum, different, product, and quotient of functions. Just pay attention to the notation. You can say f plus g of x, and that's the same thing as taking two functions and adding them together. You can subtract two functions, f minus g of x. Once again, that's just subtracting two functions as well. F times g, it's just fg of x, and then f of x times g of x. Or we can do the quotient, which is division, f of x divided by g of x, or f divided by g of x. Pay attention on this one, though, because g of x cannot equal 0. These first two examples are just going through being able to add, subtract, multiply, and divide and evaluate things. I will do that on the example video. And here's another one with the product and the quotient. So we're going to go ahead and move on to compositions of functions. A composition of a function with another function. So function f with function g is written f of g of x. And there you can see that it's written two different ways. This one looks like fog, but it's f of g of x. And then the second one is written I don't know, maybe a way that seems to make a little bit more sense, where the g of x is on the inside. So you do the g of x first, and then you plug that into the function f. But either way, they're both read f of g of x. So I'm going to go through this example with you on this one. It says find f of g of x. F of x is equal to x squared. G of x is equal to x minus 3. So why do I have these pictures of what looks to be a washer and a dryer up here? Well, here's basically what a composition of a function is. You have your f of x function, which is the washing machine. You take something, clothes, put it into the washer, it washes them, and then you take them out. Okay, but the process isn't done. You now take the wet clothes, put them into the dryer, which is the g of x. The dryer does its thing, dries them off, and then when you take them out, that's kind of the final product. So you plug them into the washer, you take them out, you plug them into the dryer, and you take them out. Well, that's what a composition is. But the last picture here is f of g of x. I was able to actually find a machine apparently that does both of them, but you put them both together. So you put the clothes in, it washes them. When it's done washing them, somehow it goes in and dries them. And that's what a composition is. It takes two machines and makes one. So to find f of g of x, we're going to start with g of x. So g of x is x minus 3. So we're going to replace g of x with what it's equal to, which is x minus 3. So now it's f of x minus 3. So wherever there's an x, you're going to replace that with g of x, which is x minus 3. So in f of x, it's being x squared, or x is being squared. So now we're going to take the x minus 3, plug that in for x, and now it is being squared. So this is equal to, if you expand it out, x minus 3 times x minus 3. So that's x squared minus 6x plus 9. So this is f of g of x. And that's what we're looking for in terms of a composition. We'll also evaluate some compositions as well. Alright, the next example I'll leave for the next example video. But it just goes through another composition, but it has you evaluate some different things. And this one you'll definitely probably want to go back and take a look at, because it's going to be talking about the domain of the composition. And then the last thing I'm going to talk about in the notes is really how you take a composition and decompose it. We kind of want to undo it. All right, I'm going to give you the h of x function. So I'm going to tell you the end result is 3x minus 5 cubed. I want you to find f of g of x that equals that function. So I want you to tell me what f of x is and g of x is. So pause the video for a second and see if you can identify what those two functions are that create the h of x. So if you were able to figure it out, this is what I came up with. And if you look at this, g of x is the inside, f is the outside. So when you go to look at h of x, what's the inside? What is happening? Well, the inside is the 3x minus 5. So that's your g of x. And then what is happening to the 3x minus 5? It is being raised to the third power. So therefore, the f of x is x cubed. And so you can kind of plug that back in to see that that works. Try the second one, example B, h of x equals 1 over x minus 2 squared. And so on part B, f of x could equal 1 over x squared, and g of x could equal x minus 2. Once again, what's the inside? What is happening? The x minus 2, and then the outside is 1 over that being squared, so 1 over x squared. So that's how you can decompose composition of functions. And that is it for this section.